we're recording. We've got some digital attendees here. So I'm Ryan. We got a couple other board members from the BEC here as well. I'm just going to start off with the sort of introduction for our speakers here. We've got a conversation today about green roofs. This is Charlie Sinkler, president of Apex Green Roofs. And you want to maybe introduce your colleague here joining us today?
Yep, my colleague Ben Shea is going to do the majority of the presentation. I apologize for my voice. I've been a little sick. I built my first green roof in 2003. I was fascinated by the technology, and back at that time, it was really about reading translated German papers. There wasn't a lot in the green roof industry, and I slowly found them to become more prevalent in design and separated my landscape design build company and focused on green roofs in 2008. And we've done over 150 projects since then. We've kind of lost count.
Thanks. Excellent.
I've been with Charlie for a few of those projects. Not all 150, but seen enough to get a good handle on what it takes to build one of these green roofs.
Excellent. Well, just a couple quick housekeeping things before we get into it. There is also a BSA event from 6 to 8 across the hall, which is an awards presentation for women in design. So we're all welcome to head over there if we feel like it afterwards and kind of join in on that. I think that's probably about it. So without further ado, let's go right ahead. Thank you very much.
Just to read the room, how many of you guys have designed green roofs? Did you get that all the way to completion, or was it VE'd out?
There were some VEs, but there's a patch of green out there.
Okay, excellent. Anybody? And it looks like we got one from the audience. So great. Should see a lot of new information here then. Here's just a bit that tells you guys we are registered with the AIA. So
yes, that was the other piece of information I had. Anybody who wants to get credit for this, there's a QR code on a sign outside the door. You sign the QR code, put in your info, and we'll make sure you get credit.
First couple of slides here are pretty boring and are sort of boilerplate for having our AIA accreditation. But basically, we're going to learn how to align critical design considerations with green roof project goals. Some key points to consider for green roof planning, potential benefits and ROIs compared to conventional roofs, and a few things about some green roof incentive policies. And green roofs were originally invented in Germany as a stormwater management tool, and that's where most of our green roof legislation and standards come from, the German FLL standards, which I'm not going to attempt to pronounce, but if there's anyone German in the audience who'd like to pronounce that text at the bottom of this slide, that is what FLL stands for in German. Green roofs are primarily a stormwater management tool, and for the reason sort of illustrated in this slide, due to the impervious ground cover of cities, 75 to 100% of cover in certain areas are impervious and don't allow for that shallow infiltration and that deep infiltration that normal ground cover would be.
Can we maybe move the owl just a little closer, just to make sure it's picking up for the people?
Here's a graph to sort of show what we mean by that, where a green roof will capture and delay the lag time of a stormwater event. In blue there, you can see the rainfall level compared to the runoff of a conventional roof, where that discharge flow rate is going to peak right up and then go right down and sort of, overload the stormwater system in the city. Whereas a green roof is going to give you that longer lag time and even capture 65% of the rainfall. There was a recent study by Penn State where they modeled Boston weather data and calculated that about 65% of that rainfall wouldn't even reach the sewer system. It would either be captured in the green roof or evapotranspirated right back into the atmosphere.
Based on how deep of
That's a 4-inch deep of substrate conventional extensive green roof. So once you get to 6 inches of growth medium, you have a broader plant palette, and it has the same runoff coefficient as park space, more or less.
So the green roof just holds the water, it's like a bathtub kind of thing, and it just evaporates, is that how it?
Yeah, it evaporates and transpires through the plants as well.
Can they hear the questions?
I'm sorry,
Can they hear the questions online?
they should be able to. If anyone can't hear any of the questions that are being asked, just ask for the speaker to repeat them.
Yeah, feel free to chime in as well, any of our remote attendees with any questions you have along the way. We're curious to know what you're curious to know. This slide is about some newer green roof technology that has hit the market in the last few years, which is purple roof technology and water detention and retention on the rooftops. And you can see here, oh nice, you can see my cursor on the screen. So you have your green roof media. Under that, you have a layer of mineral wool that will retain some water. And under that, this is like a detention layer. It sort of looks like a whole bunch of straws glued together vertically and allows a space that will that'll hold the water. And then underneath that is an engineered fabric that will slow down the rate of the water. And this fabric actually acts as sort of a Tesla valve, where the higher the flow of the water, the greater the resistance that it'll give. So it'll fill these little straw reservoirs up and hold a whole lot of water on the roof.
So I thought that historically, I realize there's different types of mineral wool, but I thought historically mineral wool is kind of like hydrophobic. But it seems like in this situation, like is there any
It's
opportunity for the
hydrophilic.
water in the honeycomb to be pulled up, or is it just slowly going through the membrane below?
It's hydrophilic, so it can be pulled up. It's
Okay.
needled mineral wool,
Okay, so it's
And-
operating differently than like what we would use on a building.
totally differently, yeah.
Okay.
In this particular application, it acts more as like a sponge, sort of to slow that water down in between the media layer, which holds some water itself and that void underneath.
And interestingly, they've found from some of the studies they've done at the plant in Virginia, where they came up with some of this purple roof with other people, that mineral wool actually keeps the root zone significantly cooler than the outside temperature too. So it's good for the plants in that respect too. The drains are very custom, so you're holding water at the drains for a long time. And
And is it also preventing the roots from getting down into the honeycomb layer, or is that not an issue if that happens?
more or less, because that's where the plants are gonna get the most water and be the happiest. So there's very little root growth below.
The thinking by the purple roof people is the only time that there won't be an air layer between that mineral wool and this honeycomb layer is during like a peak storm event, when those are completely full up. So most of the time, the roots would have really no incentive to go any deeper than the mineral wool. Because they
Yeah,
have to
just those cores are empty.
exactly, yeah.
Okay.
And here is a real life application of a project we did, I think 2 years now ago in Saratoga Springs. That was the first here in the Northeast purple roof project, 5-store condominium, 11,000 square foot of rooftop amenity space. Original stormwater plan specified a traditional stormwater tank, which wasn't, it was going to be extremely expensive and determined not viable due to a high water table. Basically, these guys were able to save an estimated between 75,000 and no, that's not right. The tank rose from 75,000 to 900,000. The solution was to upgrade to this purple roof system, which allowed them to hold all that water on the roof rather than in the detention tank. The building owner saved more than $500,000. This slide is to sort of put to bed one of the green roof myths, which is that green roofs provide insulation. And it's not exactly the right way to think about green roofs due to the effect that the water has in the media and how like sort of unstable it makes the R value. It more so acts as a thermal mass that will regulate the roof temperature rather than provide an insulating R value. And then you have the shading effect of the plants, especially if you have taller, more intensive plantings. And you have the evapotranspiration, which cools the roof as well. I can send out this slideshow to everybody at the end, but basically this is a link to a green roof energy calculator that can be a useful tool on a project to project basis. You know, there's a largely different effect thermally that a green roof will have on you know, a building that's 20 stories high and has a small roof surface, as opposed to like a large warehouse where you have a bigger roof at the surface, so, you know, a greater roof to wall ratio. And the urban heat island effect is another one of the great things that green roofs can mitigate against. You can see here, this slide shows outside air temperature, roof surface temperature of a non-vegetated roof, and roof surface temperature of a vegetated roof. And that temperature fluctuation on the traditional roof is it's so much greater than like the more regulated green roof, which is this green line here. And definitely one of the ways you can extend the life of a roof.
Is that difference in net temperature versus a black roof or a white roof?
This was a black EPDM roof.
Right.
Which you literally can fry an egg on.
Oh, yeah, no,
The black EPM.
I know.
We've tried it.
Good question. Yeah.
We got a quote from one of our attendees here, Richard. To the quoted savings, let's that back. Let's see. All right, now do I bring back?
And then below it says two more.
Ah,
Yeah.
thank you, sir. Okay. Did the quoted savings at the Saratoga project include the cost of the additional structural capacity?
That's a great question that I don't know the answer to, but I will definitely find out.
They had already, I don't know if it was a big change structurally from what was originally designed, which was a conventional 6-inch green roof that held 42 pounds per square foot. And then we brought in the purple roof concept. So I imagine the dead load did go up a little bit based on having some water holding at the drains as well, and for a longer period. But we can find that out.
Designed to the assumption that that cellular structure is full of water,
Yes.
so that's gonna add some. What was the height of that layer?
The honeycomb layer, that was 3-inch. It's very variable. You can go down to 1-inch.
Okay,
So that was designed to hold a 100-year storm event
wow.
and release it over 42 hours.
The profile of that particular project is shown here in the bottom right. You have your 5 inches of grown media,
Okay, yep.
2 inches of rock wool, mineral wool, 3 inches of honeycomb, and then your detention layer. And the great thing about this is those, they customize these layers based on how much water they're expecting to have to capture.
Sure.
You know, that
What is the cellular, size? Is it 1-inch cell, half-inch cell? I'm just thinking about the ability of the mineral wool to span across without sinking into the.
About 1/4 of an inch.
Quarter.
Pretty small.
Okay.
picture a McDonald's straw. That's
Yeah.
it literally looked like a bunch of straws glued together.
Okay, that's why there's no concern about the mineral wool sinking into those cavities.
No, and it also has incredible compressive strength
Sure.
too. They use that material in the walls of hot tubs and other things, and airplanes even. It's very, very strong. But on this project, you can see a fair amount of paved space as well. So this same buildup in the bottom right is the honeycomb and the mineral wool were also underneath pavers on pedestals too. So all of that was calculated into the stormwater.
So is water going between the joints in the pavers, or is it being channeled, underneath?
Both. Yeah.
Wow.
this was an interesting study I sort of came across today, actually, about green roofs as a CO2 reduction tool. And Dr. Takanori Kuranoma did a CO2, she did a CO2 payback study that found the green roofs had a carbon payback period of about 5.8 to 15.9 years. And I read the study and saw sort of the method she was using for coming up with it. It was a tray system with a few grass species. And I think that this payback could be done even quicker with, you know, if you didn't have aluminum edge on the project. You know, aluminum has a pretty high CO2 cost, more intensive plant material, and more locally sourced materials. I know most of those tray systems are built in a big plastic tray. I'm sure the reduction of the amount of plastic you're using would be even better. So,
on that note, what type of plastic are you guys using for the cellular structure typically, or are there options for that?
oh, the purple roof particularly,
Yeah.
I don't know exactly what type of plastic they're using.
Okay.
It's honestly not a question I ask very often. It's recycled content is what we typically look for.
Sure. I think, in certain applications, people would be curious if it's, red list compliant or whatever, what are the ingredients involved, that type of stuff.
Sure.
Okay, good enough.
And I sort of tried to highlight a few ways here to sort of model your projects for a quicker CO2 payback, which is to reduce the amount of aluminum edge. Think about maybe using filter fabric rather than aluminum edge to separate your green roofs from other areas of the roof. More intensive plant material, leafy grasses and drought tolerant perennials and things like that, and locally sourced materials.
Will you see the longevity of the filter fabric? If you're using it to separate different parts of the roof, like is it going to have to be replaced at some point, or what are the expectations for that?
I would say that the expectations are, it's a shorter time period if you want a perfectly manicured roof, but if you want an effective stormwater tool, I would say that they'll outlast the roof membrane.
Gotcha.
I mean,
okay.
It's interesting. It's interesting when you look at the difference between green roofs here in the States and green roofs in Europe. They look like a mess over there. They're just, exactly, because they're looked at as a stormwater management tool rather than an amenity or a luxury.
Yeah, they do very little maintenance on most of the projects.
It's like a
In
meadow
Europe.
instead of like a French garden.
Yes, and if it's 15% weeds and it's still serving the stormwater purpose, people don't seem to be as concerned. And a lot of the times, the plant material that we choose for a green roof in the long term is going to outcompete other invasives. It's not, especially in a thin system, it's not going to be overtaken by invasives.
When you talk about source materials as locally as possible, are you also talking about the plant, or is that just for the sort of construction product?
Sure, plants as well. That would probably be an argument for maybe using locally grown sedum plugs as opposed to sedum mats or things like our specialty trays. I know the closest any of that is grown, as far as I know, is Virginia.
In Canada.
In Canada,
both within 500 miles of.
I know before the presentation you alluded to that other project where you're working on, where it seemed like a big part of the conversation was sort of assessing suitability of indigenous, and local plants for integration on the project.
Yeah, definitely, and there are lead points associated with that as well. That's a whole nother argument on native plants and what's really a native plant anymore. But in general, it's succulents. If you have 4 inches of growth medium down to 2.5, and Ben will get into that more later in the presentation.
Slide to show some UV degradation of roof membranes. The media can act as a great protector of your roof membrane. That UV degradation is definitely one of the biggest factors for your roof membrane's longevity. And protecting it from foot traffic as well. And that's shown through some of these older projects we have quoted here. Berlin Eco Roofs, up to 90 years. Rockefeller Center green roof was built in 1930. There's quite a few very old green roof projects that are longer, they're lasting longer than they would have without the green. So,
Now, I'm not a roofing expert, I'm more of like a walls guy, but like, in terms of the membrane, are we using the same membrane you use under like a ballasted roof and you're just using the green roof as ballast? Or are you going with a completely different membrane?
You can have a green roof that is on top of a roof system that's not, fully adhered. Then the green roof can act as ballast. That rarely happens. It's usually still a fully adhered
Okay,
piece, so it's more of a coordination thing, and people do it typically like that. But no, there's all different types of membranes that we've done our green roofs on top of. We're adverse to some more than others. Some you need a root barrier.
okay.
It's an added material, and Ben will get into that component.
the only one I can think of that we wouldn't put a green roof on top of is probably shingles,
Okay.
or maybe a straw roof. But, no, most of your membranes, PVC and TPO, and manufacturers will provide a letter of root resistance. You know, they'll usually test with some fast rooting plant like bamboo or something like that for root resistance. And then if your roof membrane isn't root resistant, it's just the addition of a root barrier, which is
Because basically you're not concerned about water penetration unless you have root damage.
yeah, exactly, yeah. Some green roof benefit summaries: stormwater management incentives, heating and cooling savings, roof membrane extension of the life, and higher property values. And people always assume that we're enemies of the solar industry, but having a green roof surrounding solar can increase solar panel efficiency by reducing the times that solar panel is going to overheat during the summer. So by cooling the roof off with the green roof around it, that solar panel is going to give you a higher efficiency rating. And we have a project on Martha's Vineyard that we're excited to. I think they have some data from their solar panels through their electricity bill before and after the green roof, and we're excited this year to maybe get some real life data on how much more efficient we made their solar panels.
Definitely, yeah, that's really interesting when you guys get that, if it's
Yeah, there's no really good study in this country and in this climate yet that shows the real gains.
before and after.
Mm-hmm.
Very good.
And yeah, with your green roof, you're reducing the urban heat island effect, providing habitat for birds and insects. In fact, that's a big reason for green roofs in Great Britain, and I think Europe in general, is habitat for rare bird watching.
Do you guys have, like, let's say that somebody was interested in attracting like pollinators or something. Is there a certain height where that's just not realistic, or does that come into play?
For the elevation of the building?
Yeah, right, exactly. Like, yeah, you can plant whatever you want up here. They're not gonna come up 30 stories, you know?
No, not necessarily. I think they find a way. We have yet to do a green roof taller than 15 floors,
Okay,
but, no, you just have to be concerned about wind at that point, and you'd want to have some wind protection, like they have a leading 6 foot around the edges, especially with perennial material, because it goes so dormant in the winter. We'd be a little concerned about some of that plant material blowing off.
got it.
Or blowing off and exposing the growth medium. But no, with 6 inches of growth medium, you could totally have a pollinator green roof with all natives as well.
The last environmental benefit, I mean, who could resist those 35 juicy lead points? So this is a table that shows one of our local green roof incentives, which is Cambridge. Any new construction in Cambridge exceeding 25,000 square feet of gross floor area has to include green roof and solar energy systems, according to their zoning ordinance. And if your green roof square footage is under the amount that they require you to have, then you have to pay this. You have to pay this unit price contribution for every square foot that you reduce their the green roof that they require you to build.
We call it a fine.
Yeah,
They like
and at $40 a square
contribution.
foot, that's That's more than double the
Yeah.
cost of a green roof install in general for a simple extensive green
In
roof.
terms of their requirements, for sizing the green roof, is it based on building footprint? Or is it, what is their?
As far as I understand it, it's based on the roof area.
Yeah,
And you need to have that, the roof area needs to be vegetated at a rate of 75%. And there are areas that get to be excluded, obviously, anywhere where there's mechanical equipment or things like that, or space that is gonna be occupied by the building occupants.
75% of the roof area that is available.
Needs to be green roof,
Yeah.
and every square foot underneath, you're gonna
And
make a
or
contribution.
Green roof or solar.
And or,
And, okay, you also.
Or it could be a solar canopy over a green roof.
Maybe.
Mhm.
I mean, I guess that would have to do with light transmittance
Yeah.
too, depending on what you're
It's-
planting. I assume
it's
different light
feasible, there,
requirements.
It's feasible. We have a slide, I believe, in here.
We actually just today, got the contract for a project that is gonna be exactly like that. It'll be solar panels that are semi see-through with an extensive green roof underneath.
Basically space between the cells for the light to come through. So,
No, I think this particular solar panel allows light to pass through.
sounds expensive.
Yeah, and,
And low light, shade tolerant plants
Cool.
are going underneath it as well.
Cool.
and I mean, here's some other incentives you might get in different areas, and, Green Roofs for Healthy Cities has a great page that shows where all these incentives are effective, because not all of them are effective here in Boston, which is like tax credits, funding, stormwater fee credits, density floor area ratio bonuses. We did a project up in Portland, Maine, where by adding a green roof, this hotel was able to add a whole nother floor, 18 high-end hotel rooms. So they quickly paid for their green roof by renting those rooms out.
And the big driver in terms of people creating these incentives and policies is managing stormwater runoff. Is that really
Definitely.
the
Exactly.
number one
Yeah,
concern?
and I would say that these incentive programs are really what's driving green roofs to be a part of construction here in the US. Not seeing a whole lot of people doing it out of the kindness of their hearts. Although we've definitely seen an uptick in residential green roofs who, that nobody's making them do it. And here is an example of what our typical 4-inch extensive system looks like. And I think I heard you mention that you forget the difference between the intensive and the extensive.
Sometimes, yes.
Sometimes, yeah. So an extensive green roof is your basic.
Self-explanatory.
It's your basic green roof, typically succulent species, low growing. It's your less complicated, and it's you're more likely to see it on a space that extends. Like a big area is most likely going to be an extensive system, as opposed to an intensive system where you'll start to see shrubs and things like that, maybe trees.
Isn't that my memory device? The extensive systems are more extensive generally.
Yeah,
Yes,
best way to remember it.
more expansive.
I'm sure some of you have seen this before, but just quickly from top to bottom, we got vegetation, growth media. It's not dirt unless it gets on your pants. This is engineered growth media, and as much as I joke about it, it absolutely is engineered.
It's got like perlite in it and all kinds of stuff to make it fluffy enough and hold moisture.
The main component is that separates it from your standard soil is expanded shale. So
Expanded shale.
to lighten it, and you'll have a separation fabric between your drainage layer and the media, basically to stop any of those fines from traveling down into your drainage. Moisture retention mat, which we usually advise people to add this moisture retention mat, but it can sometimes be deleted. Basically a way to hold a little bit more moisture under that drainage layer. And then you have your waterproofing in the roof deck. And it is to show sort of the difference between how a green roof would look on a
Oh, we had a question. Alright, let's see if I can remember this more. Chat. Okay, got a couple of questions here.
Okay, I'm seeing a question
Alright,
about,
so we got a question about, can we talk a little bit more about the type of solar panels that you can install green roof under? And why isn't the drainage layer under the moisture retention vent?
I guess, so I'll take these in order as far as the type of solar panels
We do have a slide.
that green roofs could be installed under. There is a solar panel slide in here.
I think you incorporated a solar panel slide.
I was going
Sure.
to incorporate a solar panel slide. Our next presentation that we built, there will be one. But yeah, I mean, underneath a solar panel, there's still plenty of light there. So if there's so many photos showing, especially ballasted solar systems, which are great because you don't need any roof penetrations. You know, a lot fewer weak points than something that's mechanically fastened to the roof deck. But basically, it would be like a drain board similar to this that's rigid, and it would extend out past the solar panel and just be ballasted by the green roof media.
So the idea being that, assuming that the panels are tipped to optimal orientation and they probably don't start right at the ground in case it snows or whatever, that you're getting light from, you know, at least 3 different directions.
Sure.
You know, that's enough to keep shading.
Yes, definitely. And we've done a number of combined green roof and solar installations. The type of panel isn't really relevant to us.
You could spend more for a semi-transparent, but you don't have to.
You don't have to, and we've had green roofs come right up to the solar panels in the past, and maybe vegetation-free zone right around them. That's just a 1 foot area of 1.5 river stone. One of the first install we did combined solar and green roof was at WGBH headquarters, where they have about 10,000 square foot of solar panels that were already there. And we came close to about a foot away from the solar panels with about 6,000 square feet of vegetated roof going around the perimeter. And we've done several other like that. We've yet to build one where we have panels on stanchions or ballasted that are above the green roof where we've interplanted underneath, but we do have one coming up soon. And there's many examples in Europe of those systems.
All right.
Yeah, I'm happy to follow up too with some data sheets on some of the stuff that we've mentioned along here.
And on the other question on what the retention sheet on top of the drainage layer, we want to encourage water to be at the very base. So typically having the most fabrics for retention sheet hold 0.12 to 0.15 gallons per square foot. And having that water at the base layers is best for drought. And that will slowly wick water up through the drainage layer to the plants. The plants will also go through the filter fabric on the drainage layer, depending on what type of drainage layer it is proven root permeable. So those roots go all the way down into the very base layer and actually infiltrate that retention sheet. We've pulled back areas of green roofs, and that base layer is just full of root system, which is what you want.
And I guess Richard's question is there any concern about having water in that mat right on the membrane, like long term?
No, there's never been a concern from roofing manufacturers that I've heard.
Okay.
On that end.
So a lot of the, new codes ask for a ton of insulation on our roofs, maybe 6 inches, 8 inches more of XPS.
Mhm.
Does that really introduce any new design parameters or concerns for us, or can we just move everything up 6 inches? We're still going to be operating this green.
Building a green roof on a heavily insulated roof as opposed to, is that the question? Are you talking
exactly.
about?
Like, I mean, in the pictures behind you, the insulation layer looks like it's 1 or 2 inches thick. But if we're like 6 or 8 inches thick, are we designing this way differently, or is it just gonna be a lot of the same, but move it up?
There can definitely be wind concerns on inverted roofs. you know, because the green roof is now used as your ballast to hold that insulation down. Especially have a project that's going to be insured through FM Global, and you have to start abiding by their wind concerns. But I mean, typically no. I mean, a 4-inch system, we're not so much worried about it blowing away. The only potential problem is if you know, in that sort of scenario, if you did get wind scour in a corner of your green roof and then some of that insulation was exposed, you know, you'd want to make sure. And there are some slides later on in the presentation that shows sort of some of those elements we incorporate on projects where wind is going to be a concern. But no, other than wind concerns, I wouldn't say there's
Whatever the depth of the insulation is, it is on our end, whether it's an inverted or a you know, fully adhered roof with insulation below. It doesn't have any influence on what we do or
the only
how it's working.
The only thing I will say is on inverted roofs, we're often asked to use like a vapor diffusion fabric in between the insulation and the drainage layer for the green roof.
You can't have that water holding fabric directly on top of insulation. On you know, XPS insulation, it needs to be that vapor diffusion open for them to warranty the insulation itself.
I saw Rob chimed in, asked if you guys could talk about purple roof. I think he might have come in a little late, might have missed some of the earlier slides. But maybe we'll just kind of recap on some of the benefits of that before we wrap up.
Yeah, definitely.
This image is, oh man, I completely forgot I was gonna bring some drain sheets to hand out. But here's your 3 main types of green roof drainage. From left to right, that would be your like bare bones green roof drainage layer. It's not there to hold any water. It's just to get that water from the bottom of the green roof down into the drains. So basically, you know, you'll see those little filaments there will create a void for the water to run into the drains. Over on the right here, it's kind of a messy photo, but you can see where my cursor is. Well, starting from the top, this is your traditional green roof. I think this is probably about 4 or 5 inches of green roof media. And then you have a separation fabric. And underneath that, you have your drainage media, which is no organic content, just your expanded shale. You know, 3/8 expanded shale to allow that water to drain through this aggregate. This is probably the most popular way to do it over in Europe, and a lot of the early green roofs were done this way with this drainage aggregate. And then on the right, this is what we probably prefer to use the most, is a drain plate or like a dimple drain board. And you can see, if you look closely, here are the holes where the water is allowed to run through the drain sheet at the crests of these dimples here. So this whole cup here will fill up with water before this board starts to drain, to allow a really good reservoir for those plants to drink from. And having taken apart a few green roofs, usually when this sort of drain plate is used, you can see inside those cups, there's a big ball of roots that have established themselves right there to sort of drink from these drains, and it allows your green roof to be a little bit more drought tolerant.
What is that material?
For the drain plate, that would be recycled HDPE, or just, you know, it's just recycled plastic.
And do they do that in sheets or coils, or what size is that stuff?
Most common way to see it is in like roughly a 4x8 sheet.
Okay.
But it seems like every manufacturer has it a little different. And I don't think any.
Kind of button up next to each other?
Yeah. Some of them are smart enough to make it twice as long as it is wide, and some of them aren't. So. And then this is something you would more likely to see in a roll. I'm not sure it's so much interesting from an architect standpoint, but from an installer standpoint, you can fit probably 20,000 square feet of this drain sheet on a couple of pallets, where this is going to take like 2 tractor trailer trucks.
Well, the one on the far left is reminiscent of some of the stuff that I've seen and put behind, like say flat lock panels, you know, just to provide like a minimum amount of.
It is same thing. Cold on used to make
Same idea.
Mm-hmm. It was repurposed in the green roof industry many years ago.
And just to quickly go over these three, and when would be the best time to use them? You'd want to use this one when you have a project that's got some budget concerns. It's going to be the cheapest by a fair amount, and where we don't necessarily need all that much water holding. Dual media system would be great for a project where you're adding your media with a blower truck, because it's going to make it really quick. So if you already have a blower truck set up on site blowing your media, then blowing in that extra drainage aggregate is going to be pretty cost effective. And then this one on the right is typically the go-to, and especially the go-to if you want to have a bit more drought tolerance and extra reservoir for those plants to drink from. And here's a bit about some FLO guidelines on growing media. And some of the things they're tested for: mineral content, organic content, granulometric distribution. And they're usually made up, depending on what kind of plant palette you're looking to grow, 80 to 40% coarse lightweight aggregate, and less than 10% organic matter. That organic matter is going to be a little bit higher if you're growing a more intense plant palette, flowering perennials and shrubs and trees and things like that, and a little bit lower if you're going for more of an extensive succulent plant palette.
And one of the keys to the growth medium is having you have about a 10 to 15% compaction rate, and you have a certain flow rate. So regardless of the storm event, it's still moving water at a consistent speed. Many of the early mistakes in green roofs and the sod roofs, people tried to steer away to more of a conventional loam, and you can have major problems in clogging of drains, invasives coming in. It is a very key component to making it all work, and having that low organic rate makes it so you're keeping the desired plants that you want, and you're really picking plants that do well in this specific growth medium.
It seems like if you were to pass all these other tests, frost resistance would just inherently be there. Is that kind of like a belt and suspenders thing? I mean, when they're testing for frost resistance, really they're looking to make sure that you're not retaining too much water and therefore having, freezing issues, or?
Yeah. And heaving and the freeze thaw can be bad on plants as well.
Right. But
having that pore
if you get everything else right, then you're gonna pass your frost resistance, right?
Yes, exactly.
Okay.
Yeah. The pore space.
Let's sort of start picking up the pace here. I think we're getting a little late on time. Some establishment options for our extensive green roofs. You got seed and plugs, pre-vegetated mats, and trays. These seed and plugs are going to be your most cost effective. They're going to come in like a 72 cell tray, and we typically will plant them at like 2.2 per square foot. And these are going to take 1 or 2 growing seasons to get your full coverage. But one of the advantages is if you wanted to get a little bit more color coordinated with your design, you can sort of clump together sedums that are going to bloom in a certain color, and you can maybe make shapes and big swaths of different foliage cover. Sedum mats, these are by and large the most common on extensive green roofs. Like I'd say 90% of projects we do are going to be sedum mats when it comes to extensive. On commercial especially. One of the big holdups with these, especially with smaller projects, is the high delivery costs. I mean, $4,000, $5,000, $6,000 to get a refrigerated truck onto these sites, and you get limited color coordination. Although there's a few growers who are doing different like color palettes of mats that you can arrange in different designs if you want, and they're good because they're covered right away. Like as soon as you roll them out, they're fully grown in.
What's the importance of the refrigerated truck?
To keep the plants alive in the hot summer months.
If it's a regular box, they would just cook and dry out.
Typically in June, July, and August.
Yeah.
Yes.
So you can see here, this is how they're delivered. Like they're rolled up like sod on this coir mat, and if you let these things bake, they're not going to survive.
Gotcha.
They need to go down that day.
And they need to go on pretty quickly.
Yeah, exactly. Yeah.
What kind of coverage do you get out of one roll, or are there different options?
So for mats like this, it's about 25 square feet per roll, and then there's also some growers making 1x2 tiles grown on a different type of substrate.
Coconut fiber.
Yeah, like coconut fiber stuff.
So like, okay.
On quar.
So when you roll it out, like what are the typical dimensions of all these things? Like you said, it's 35 square.
3 by 6. Roughly 1 meter by 2 meter.
Okay.
Most of the growers use the metric system. Yeah,
Yeah.
in fact, all.
They're using German standards.
Yeah, sure. Yeah.
In German.
And then pre-grown trays. This is most likely going to be your most expensive option. It's pretty much the same amount of color coordination as your cedar mats, but they're going to be fully covered right upon installation. And these are great for projects where your other establishment methods aren't an option. Like say you can't reach a surface with the crane, and you have to bring everything in through the building. These are nice because everything's coming in at once. It's your media, your drainage, and your plants. We had to do that on the Prudential Center.
I thought that looked familiar.
I have a question, you might get to it in a few slides, I don't know, but like, so I'm looking at that kind of tray or whatever, just that kind of plant material or whatever, you know, I guess this varies based on the project and the type of plants and species and all that, but talk to me about maintenance.
Yes. Yeah. So we have some slides
Okay.
coming up on maintenance.
Very little.
Very little,
Typically,
yeah.
we include 4 visits per year for the first 2 years on commercial projects.
Okay.
Pulling weeds, checking, getting a soil test, making sure all the right nutrients are there. Very, very little.
Sorry, just to back up 1 second to the other side, like, so what if it shows up like that, and then what? Like that black tray isn't a permanent part of
The black tray is permanent.
It is permanent.
Those white soil elevators will come out, and this varies from
One-
manufacturer
That
to
allows them
manufacturer.
to then grow together and connect and whatever.
Yes, somewhat.
To a certain degree, yeah.
Okay.
I mean, you're usually going to continue to see that grid pattern
Okay,
for
because the
indefinitely.
black is permanent.
Yeah,
Those trays are permanent.
right.
Okay, so those white pieces are just individual pieces that come out as a sheet.
Yeah,
Yeah.
so that soil is up probably, maybe an inch above the rim of that black
Okay,
tray. And once you pull those up, the soil sort of migrates into the openings.
That particular system, the tray is just 2.5 inches. It's permanent
Okay.
plastic,
got
and
it,
that's a 4-inch system.
got it.
Here's one of our details with really tiny words. This is just a green root scupper shown here. So this would be a drain access chamber here with like a removable lid against a through wall scupper. This is how we would do it, in a through wall scupper scenario. And there's your 8-inch minimum of vegetation free zone, which is usually 1.5 to 2 inch wash river stone. And I have a slide coming up on that. There's your aluminum edge and your standard extensive buildup there. Here's how you do it. Same sort of deal with an internal drain. You have your drain access box over the drain itself in case anything happens. Then you have your 8-inch vegetation free zone around it. You can see it from a plan view right here. Vegetation free zones are important to sort of have that final runway for the water to come off the roof, especially in a freeze thaw scenario in late winter, early spring. If that soil was saturated and then frozen, you definitely want this final runway against the drain so that it allows it to be resistant to clogging. Here's some examples depending on how much your client wants to spend. Regular river stone on top, salt and pepper beach pebbles, and then Mexican beach pebbles at the bottom.
Do you ever have issues with the stones getting, mossy or slimy or, anything like that or something?
I can't think of them getting mossy, but the plants certainly like to grow into them, especially the sedum species. They'll grow right into the, which has never been a problem. I mean, we think it looks great when sort of these margins.
Surprising, you'll see quite a few plants growing right in the stone.
Irrigation's great, and we always do it on establishment with a temporary overhead sprayer like the one I have shown here. But it takes away from your lead points to have permanent irrigation. Some projects it's definitely a good idea, but we always advise people to design the plant palette to survive without irrigation on particular projects.
Well, it seems to me if you're like your primary goal is like minimizing stormwater runoff, and you have that go into a holding tank, and use that to water your roof, what's the problem there?
Yeah.
Right?
Yeah. So, I mean, if you're recycling stormwater, that's great.
We have done some systems with gray water,
Plants don't care.
Right.
usually.
I would say most of the irrigation design that we see though is not that.
Yeah.
We have done many amenity decks where it's more maintenance and you're supporting trees and shrubs and flowering perennials that you see more at a ground level landscape. But to me, there's a place for that for amenity space, but the true green roof, I think it defeats the purpose. Having to have a permanent irrigation. When we always make sure you have a hose bib available at the roof surface is
Right.
surprising how many times it's not incorporated into the design.
Well, the fire department makes sense.
When we're approached by a client that wants to build a green roof, here's a list of the questions that I like to ask. How's the space being used? What's the accessibility of the space like? And what's the aesthetic? On a commercial project, what level of green building certification is desired? They're not necessarily asked in this order because usually dead load is the first question you ask. How much weight can the roof support? What type of waterproofing and how is the green roof being kept on the building? Here's some advice for if you're designing for a really cost-effective green roof. You're going to establish it with plugs. Go down to as little as 2.5 inches of soil, which is site-specific, but usually you can get away with it. Non-proprietary materials can save you a lot of money. I mean, some warranties can be great, but
Through the waterproofing manufacturer.
through the waterproofing manufacturer, yeah.
Not necessarily cost effective.
We kind of talked about eliminating aluminum edge where possible.
How do you detail that where your medium meets the gravel, if you're eliminating it?
I would say
You
you
turn up
detail it.
filter fabric.
You would detail it exactly the same way as it's detailed here.
By the gravel.
Exactly. Yeah. It just takes a little bit more care to when you're doing it to trim where it says perforated aluminum edge. I mean, that's where your filter would be turned up just like that. And you just have to take a little care to sort of feather in from one side and the other as you build up that piece of filter and cut it off flush at the top.
Richard just asked a really interesting question. What is the maximum slope that you can do, maximum pitch you can do on a green roof?
Anywhere from a 2.5 12 to a 7 12, you need a slope retention panel. And I believe we have something in that on the slide. Once you're beyond 7 12, you would need structural ribs. And then it gets super complicated and you have a living wall.
So slope retention becomes basically, is it kind of like almost like snow retention, like it's tabs or?
There's
something?
different systems on the market and I believe we have that in here.
We do. I have a few good photos showing some slope retention systems.
We'll get there, Richard. And then one last question about the two, you said 2.5 inch kind of minimum. Is there a specific type of medium you need to use when you get into that or is it kind of still?
Same medium, but you want to have water holding and definitely have a drain sheet and a fabric protection retention fabric as a base layer.
So it doesn't get oversaturated or dried out?
Yes, you want to hold at least 0.3 gallons per square foot between the drain sheet and the retention sheet.
Oversaturation isn't so much a problem. I mean, this stuff is definitely designed to get water off the roof when it needs to, but drying out not drying out is definitely a concern.
Got it.
And an economy of scale is huge for designing for cost effectiveness. I mean, the difference in cost between a project that has 1,000 square foot of green roof and 2,000 square foot of green roof is it's not even close to twice the cost. I mean, your biggest costs are delivery of the materials and your crane and mobilization, stuff like that. It's not so much your square footage of the green roof itself. If you're designing for stormwater retention, definitely going to want to go with a purple roof or something like that, or a purple detention, something with detention in it. Your drain sheets with water holding, your mineral wool layers, and consulting with the civils for possible ROIs, like we talked about in that last project. I mean,
I know Rob wanted to talk about purple roof a little bit. Like, in terms of the definition of purple roof, like I understand it has the typically cellular water retention layer, but like, is there a factor in terms of like how much more water it retains than a green roof? Like, how does that conversation happen?
That conversation happens directly with the Purple Roof team, and they have like some really advanced stormwater modeling tools on their website where you can side by side, like here's the green roof they're thinking about, and you build the green roof up, and then you type in, here's how much stormwater we need to capture, and they'll say, here's the system you need. I mean, they're very advanced when it comes to
That's where they start to determine 1 inch, 2 inch, 3 inch deep, whatever.
Exactly. You can plug in the soil depth, whether it's 1 inch of honeycomb versus 3 inch, 1 layer of 1 inch needle mineral wool versus 2. So you can really, figure out what you're gonna do. And that's the first, green roof system that's really come up with how to deal with detention.
Yes.
And obviously there's a premium with all of those materials as well. So, it's gonna be more expensive than the typical, extensive green roof that is really, just dealing with retention and not detention. So the civils really need to be involved and understand it early. So it's incorporated into the stormwater plan, and there's potential savings on the underground retention and detention tanks.
Purple Roof
is slow rate.
Purple Roof is just one manufacturer of a blue-green roof, and there's quite a few other manufacturers that either have or very soon will have blue-green roof technology, like BioRoof or.
That was my next question, was like,
Yeah.
I've asked around and not a lot of people are familiar with purple roof, so I was wondering, is it like a product or is it
It's non-proprietary, and they're working on selling to some different waterproofing manufacturers as well, or direct to installers and designers like ourselves. There's a number of options, but they had some funding with some outside partners to do a lot of the testing on this to solve this problem with.
So in the industry, are we calling it purple? Are we calling it blue-green? Are we calling it?
The Purple Roof name is proprietary, so I think
It's
blue.
based on being a blue-green roof, but blue and green together are purple, which is, I think, how they came up with it.
Yeah.
The name.
Are they then?
Almost. They were almost there.
Is it?
It is.
Yeah, it did be some color theory, but.
Yeah.
Here's some design considerations if you want bees up on your roof. Towards the end of this presentation, we have quite a few just sort of showing off our roofs. Some environmental benefits. I mean, the Deerfield Academy, these guys had bees up on this roof at the Four Seasons. I think at this time, there's a bee box shown there in the back, and they're also growing some edibles here, some herbs that I believe the chef at this hotel was using for a little while.
They were for a while, yeah.
Designing for accessibility and amenity space. I mean, definitely thinking about herbs and edibles is absolutely doable in a green roof. Taller plant material to encapsulate the space. Mounted XPS to create topography. I have a good slide coming up on this. Can sort of explain it a little bit better. And walkable surfaces and steppable plants. So here's a project that I believe was 4 inches of media continuously throughout. There's only 4 inches of media through this whole thing. And underneath the drainage layers here, there's XPS stacked up and formed into mounds. So especially for a project where you're worried about how the dead load is going to handle the roof, these portions where the XPS are mounted up aren't any heavier than the rest of the roof.
This might be a dumb question, but from a building science perspective, I'm looking at you. Is there any like reservations about wildly changing insulation depths, or is that?
Well, that already had an insulation there. We're adding to it, so we're ostensibly adding some additional R value.
They're getting a little better. Probably not moving the needle all that much as long as we're.
There's no like downside to that.
As long as the wind output and we're striving for here, everything's secure.
Okay. Interesting. The effect is cool.
Yeah,
Especially with the mountains in the background, it feels.
that was the purpose of that one.
This was one of the probably the more
Gladwell's house.
This is probably one of the more mellow versions of this mounting that we've done. There's some more extreme cases, and it works really great to encapsulate a space and just make it a little bit more interesting. I'm sure I don't need to inform you guys much about paving options, but here's a few of our roofs, showing some of those options, concrete porcelain pay. And then another great option is just to dry lay whatever you want right in the media. Bluestone steppers, things like that, as long as the dead load's there. This is the Archer residences. It's a pretty intensive amenity space with some edible plants here and some trees.
The only reason I have any idea where that is the dome in the back. Right?
Yeah, it's a good marker.
You cannot fly a drone there.
I doubt that. I don't know what to.
It wouldn't even turn on.
Here's another amenity space at 101 Seaport. And here's a good slide sort of showing those steppers just dry laid right in the media. And they look great if you want sort of a hippie space like these guys did.
And if your client's willing to respect a suggested boundary.
Yeah. Don't send this one to OSHA, please. Rooftop food production is absolutely doable and is being done already. There's a few places, Whole Foods in Linfield and this university in Waltham. Green City Growers is usually who we contract with. We don't produce food ourselves. We will build the green roof, and then sort of Green City Growers takes over from there most of the time with the programming for food production. But
So are they just doing like shoots and starts and microgreens, or do you have enough medium to do like full mature, like
Anything you want. Yeah.
my brother toured, he was volunteering with like a food bank and farmer's market in New York, and he toured a big rooftop urban farm in Brooklyn. And it was like the real deal, they were getting a pretty significant amount of produce out of there.
No, it's significant. You can do very well with it.
they usually want between 8 and 12 inches of media, and that's for vegetable production, but turns out you can do cows and chickens in only 1 inch of media.
What?
Here's a few other educational spaces. It can be a great like programming thing for schools and things. Get like beekeeping and flower growing and assessments and insect and bird watching up on your educational roofs.
The one in the upper left was funded by the New York State Sewer Department as well. And that's an outdoor classroom. It's at the Donut Stewart School in Rensselaer, New York. And it has Southwest natives, New York State natives, all of our plant community, and then quite a bit of just extensive readers. So it's part of their curriculum now.
I'm sure you guys are familiar with some of these products here, but this is what we typically use when there's wind concerns. We'll bury this portion of this disc anchor before any of the media, and we'll bury that all with media, and then plant on top of it, and then put some of this wind mat down that you can see in the right of this photo, and then cap it off with the top of that anchor so it's all ballasted by the media. And these wind blankets can sometimes maybe they'll go under a sedum mat, or sometimes they'll go over the sedum mat, sometimes they'll go over cuttings, or sometimes planting bigger plugs. You could just make small cuts in this mat and interplant. But they're especially important on the leading edges of the roof. And that's typically what we'll see is we'll just do a border around any penetrations and leading edge of the roof with this wind blanket. And we advise with high wind projects, you want pretty fast establishment with densely packed plugs or pre-vegetated mats. And you definitely want a vegetation-free zone at the perimeter to help with sort of that wind turbine effect against the parapet wall and things like that.
Those disc anchors attached to anything, or they're not?
They're ballasted by the media, so that this big disc at the bottom will be held down by the soil above it, and then this top disc just pushes down the anchor as far as it'll go until it's tight. And
it's a heavy duty plastic, and it's about 6 inch in diameter.
Designing for slope, like Charlie mentioned, anything greater than 2.5 over 12 pitch requires slope retention considerations, and you're going to have to either structurally support these from the top, bottom, or in the case of a pitched roof that has an opposing pitch on the other side, they can be like draped over a roof and counterbalance as well. Draining edges are definitely a concern when it comes to sloped roofs. That final portion of the water coming off the roof definitely gonna want to see a vegetation free zone there. And just like with wind, fast establishment is key. Those roots are really like, they're a great preventer of any soil erosion. The roots grabbing your soil, and they're extremely project specific. Definitely best to consult with a green roof professional, someone who's seen these sloped projects before, because they're just so different from project to project how they behave. And here's some photos. So this would be retained from the top. This is like a flexible rubber here that creates cells. So it opens up to create these cells. And then you have cable, and then you have cable running through these cells that's supported at the top, and there's stops along the cable. So these cells will be filled up with media, and then plants will be established on top of them.
So it's like, there's like pockets.
Exactly, yeah. So when it shows up to the site, it's like completely flat and it opens up like a web. And then,
Do I assume that like 90% of the roofs that you've done are
yeah,
flat?
Definitely. We've only, out of over 150 projects, I think I've done 4 sloped roofs.
Yeah, that's what I was gathering.
People shy away from them in general.
Do you guys have any reservations about it, other than it looks more expensive?
I do not. I like them because they're more visible. They're more of a challenge. Once you get to a 7/12 pitch, which we have done once before, you really need to have some sort of supplemental irrigation because it's going to lose its water much quicker.
yeah, no, we love doing like the slope retention stuff, and it allows us to sort of engineer like parts that are project specific, especially when it comes to mechanically fastening the slope retention to the roof, engineering how you're going to get that done, because it's not a saturated market of products available for that. So a lot of the stuff is like custom from project to project stuff that we have to get built to keep the stuff on the roof.
Because of the shear forces, there's a lot of engineering that has to go into it. So I think they're more often seen on high-end residential than on commercial.
Yeah, us and Ned will be building a 9/12 pitch, hopefully
At Ned's house.
hopefully next year. This bottom photo shows a similar system, except it's supported from the bottom. So these are like plastic squares here that interlock, and they're supported from the bottom, and you basically build them up, and they act as the same thing. It's sort of just pockets for that media to sit in.
But they're essentially all stacked up in compression.
But these are very rigid and they're stacked up. Yeah. This is a Zinco product, I think. Here's some photos showing off some of our sloped green roofs. This needs to be updated because we probably did our most aggressive slopes this year. Photos forthcoming.
Well, that was interesting though. You have basically an internal valley there. Do you have any, extra robust water management going on there, or?
It is the same drain sheet. It's all pitched about a 212 towards us as the viewer.
Right, yeah.
So
That's enough to keep everything moving.
It is. That's a biomass heating facility at Hotchkiss School. And what's interesting is because of prevailing winds and drier or wetter areas, you do see a difference in the plant material in the heat of the summer on some of those mounds. It always maintains at least 80% coverage, but you can see where the prevailing winds come in, and some of those plants do better than others. Dried out a little bit on the tops of the ridge on the windward slope.
Sure, yeah, just like you would lose during the top of the mountain.
Definitely.
Very cool.
And the weeds love the valleys, and the sedums outcompete the weeds up at the tops, which is
very cool. We got another question here. Is the mat you showed suitable for coastal wind conditions, like a mile or less from shore?
It absolutely is. We did 2 with wind mats on Martha's Vineyard, one of which had recorded 92 mile-an-hour wind speeds on the roof. They have one of those little weather stations, and so yeah, we have one of those installed on that roof, and it's working great. think we're over time here. I'm gonna try to just get through the rest of this. Some other factors is EVFM compatibility with your waterproofing. I mean, we could probably spend another extra half hour talking about making sure your roof is leak proof before putting a green roof on it.
Electronic leak detection has become pretty better understood and more standard in commercial applications, that you have a roof system that is compatible with that electronic leak detection, whether it's permanent or not. And you can find a leak electronically within a foot, which is a huge
Just give me
benefit.
an idea for another, presentation, another topic here. So that's something that's becoming pretty common.
Yeah.
Is that done with like a drone or like a handheld?
No,
So-
it's basically,
Nice.
you can do it with probes if it's a metal deck or concrete deck. On a wood deck, you're gonna wanna have a metal, there's a mesh that goes underneath the membrane, and then a wire system taped around the perimeter and to the drains that can be hooked up at any time. So you can triangulate a current. You're basically creating a positive and a negative between on either side of the membrane. So you saturate it and you can find it. We found staple holes on one we did at MIT
So,
just prior to installing the green roof.
so this is something that a green roof contractor would sometimes offer, or this is something you would like to see done?
We would
before you
demand.
show up?
It's typically in the in Division 7 in the roofing
Okay.
package, and the roofers and roofing manufacturers are all pretty well versed in how this goes in and
Like I said, I'm not a big roofing guy, but so this is something that's been around for a while now? And you
it
just
has
make
been.
sure
They
that it's-
originally did it for testing waterproofing and underground contaminated waste vaults and things like that. It's been around for a long time. It's been in our industry for 15 years or more.
So you
and
don't
it's
get any
great.
pushback when you say, hey, we wanna make sure you've done this before we show up.
Yes, we want ideally an electronic leak detection or 24-hour flood test
Okay.
before we begin. So if there's a leak, there's no finger pointing.
Right, yeah,
And
for sure.
we take the blame. If we happen to have an accident installing it and make a hole in waterproofing. But it's becoming more and more standard, and I would highly recommend it, especially if you have an amenity deck and pedestals and pavers. If you have a leak, you want to be able to find it without pulling off a large area of vegetation or pavers or planters. Can get expensive because, as you know, a leak can come in 20 feet away from its source and structure. So
Fall protection requirements, especially for your maintenance people up on the roof, it's definitely something you want to think about. And just sort of along the theme of ballasted stuff, I mean, having a green roof allows you some great opportunities to have ballasted things on your roof, and fall protection is one of them. You can see this mat is just ballasted by the media around it and works as a single man anchor point. So it's great for not having additional penetrations in your roof. There's a few healthcare environments we have. This one on the bottom actually has that ballasted fall protection throughout. And you can, this looks like a rendering, but it's a real photo actually, and you can kind of see
it's 2 years old. We built that.
Yep, the light conditions are a little bit strange here, but you can kind of see where the different colors of sedum mats sort of make a design here.
That's about 2 acres of green roof total.
This is a slide that I like to make sure to say that this is not a green roof we built. What we're pretty sure happened with this green roof that collapsed was that there was a freeze thaw. The green roof was saturated and then froze, and the water ponded up on top of the internal drain that was supposed to allow water to come off the roof, and it just became too heavy and collapsed. Another reason to have vegetation free zones. Windows and glass railings get overlooked so much when it comes to like projects that have green roofs, and their effect on the green roof is almost always overlooked. This is a project here you can see. I mean, these showed up probably 2 weeks before fully vegetated, and they just got fried by this window right here because it's a thin area. You know, we were able to bounce them back a bit, but and you know, these guys here, you can see they don't care. They're standing on the green roof, and you can't really blame them because there's nowhere else for them to stand. But you definitely want to be aware of reflected light when it comes, and refracted light as well, if you have glass railings on the site or.
And window wash
And if
chemicals.
If you're planning ahead, you could potentially specify a type of glass that's gonna be a little more diffuse, maybe like a frost.
Exactly, yeah, exactly.
Yeah.
And just have your green roofs near the glass be bigger, this area would have no problem surviving if it was more than, that's 2 feet wide right there, it's just.
Sorry. Just back to the last slide for a second, could that have potentially been prevented if there was some kind of like electric resistance heating of the drainage pathways, or is that something you guys ever do?
Yeah, I was actually at a project today where they have that, and we had to go through some extra concerns for those heated drains to not wake up the plants around it during the winter time, because the plants have to go dormant in the winter.
Sure.
And if they're kept awake by a dull heat coming from that drain, then they're gonna die around thing, but
I mean, oftentimes, like, I've got electric resistance heating on the supply line from my well, and it's like, I turn it on if I need it. It doesn't just like idle along, right?
Sure,
If there's an issue, I don't have to like go dig up frozen ground to deal with it.
Yeah. Some people put the heat trace in. It's not really needed in my mind. It's not necessarily the climate.
If you do the rest of the design.
If it's designed right and you have that vegetation free zone, I don't know if the structural engineer had an issue on this as well. This heavy snow load, I got this from a colleague at Seacus Arnafil.
So in your opinion, the electric resistance or heat traces is not something that should be needed?
No, if it's designed right, the soil's gonna have to move water. But if you don't have that vegetation free zone, let's say you have a fabric around a drain and soil right up to it, that fabric can get clogged by the roots and everything. So that vegetation free zone is a fail safe for the rare conditions when you might have a fully saturated and then frozen green roof and then a large rain event where it would be sheeting across the top. It's very rare, and in Germany, a lot of the projects don't have that vegetation free zone around the drains. There were some problems in the early ones in the US and Chicago where they had that problem and the water wasn't getting down and they collapsed a few internal drains on commercial school buildings.
My other thought, when I saw that with the vegetation getting fried by glass, basically, or by getting solar, or sun going through or reflecting off the glass. I was thinking, like, let's say your guys are getting called into a new project, it's right in the seaport here, or it's right, downtown or whatever, and you're doing this 10-story building, you're up on the top, and then on 2 sides of you, you have these 30-story buildings with reflective glass, so it's just a glass curtain wall, the whole thing, and you're right there, you take that into account when, like, the light reflecting, the sun reflecting, like, magnifying glass kind of.
Definitely, but it's really about being very close to the plant material, not necessarily off of another big building.
All right.
To me, that's just an advantage a lot of times because you're getting more light.
Yeah, right. Unless, of course, it's parabolic and you're melting the mirrors off.
Yeah.
That's another story.
This slide seems not all that important, but I mean, this is something we deal with on probably 75% of our projects is people walking on our green roof, especially people that have to be up there working on the roof.
I mean, and coordination of trades is very important.
It's coordination, but I mean, even more than that, it's really easy for us as green roof installers to yell at the people walking on the roof, like, what are you idiots doing? But I mean, on this particular project, I mean, you can see here, where my cursor is, that's where these people were intended to be walking, and they put a gas line right through it. And this is the pathway from one door to the other. And there's nowhere for these guys to walk. I mean, it's definitely something that can be thought about and alleviated on the design side of things. Making sure you have pathways especially pathways that are realistic. I mean, if you've ever been to a college campus, you've seen those corners where there's a pathway, like right through the corner. I mean,
so what my college did was they would just, anywhere that paths established, they would just formalize them. They would just pave them. They're like, okay, fine, you're gonna go that way, we'll make it a path.
Right.
So there's just, this is very organic, like, web of paths everywhere because they're not gonna fight you on it. They're like, okay, fine, That's a path now.
Right, if you have a roof with a lot of mechanical equipment, you better just draw straight lines from that door right to the mechanical equipment, because that's what's gonna happen anyway. And these plants are, we had to replace all of these plants, and it was at a large cost to the project team.
Is there anything about like sequencing or phasing? Like, is there a way for you to like kind of be the last ones on site, or does that not necessarily work out?
Yes, definitely. It's important for it to be done in the interface. And sometimes we do everything but the plantings until all other trades are off the roof.
Okay.
We just get the soil down. But
Because they can walk
in
around
general,
some
we
substrate.
want to, before we mobilize, we want to see the roof surface and make sure siding is done, that the glazing is done in areas where they could potentially be damaging the plant material.
Yeah, it's tricky too with green roofs, because we have to install, like our particular contracts that we give to people it's between April and October, beginning of April, end of October. And we're very flexible like I was at a green roof project today. We're very flexible if the weather permits. But, yeah, I mean, if you can't get that, if we're almost the last person, and then, the last person's maybe pushing us into January, like, sorry, now you have to wait until April. So there are definitely some projects where it's tricky, and you just have to put the green roof down and make the right concerns. But ideally, yeah, we're the last people up on the roof.
I have a question.
Yeah.
So this is sort of a dumb question, but it falls into what you just said. So you guys don't need to finish your work or install the green roof, even if it's on the drawings and in the project and the contract, for that building owner to get a certificate of occupancy, correct?
It's probably project specific, and it's probably project specific, especially for those, like on the project that comes to mind, on the one that showed trampled plants.
Yeah.
They use their green roof to get a density bonus to allow them an extra floor. So I'd imagine that if
But
that's
I
looped
think
into
in
their.
general, yeah, you're right.
Right, like the
Like this
local.
pity saying you didn't give us what you said you would.
Yeah.
Hold them to it.
Right,
Yeah.
right. If the green roof is tied into their licensing or requirements, I'd imagine that it's project specific too.
But from like a health and safety.
Yeah, right, and from like, people moving in and occupying the building.
Yeah,
it's
yeah.
gonna happen.
You're right,
Yeah.
right.
So this slide is just emphasizing to design your plant palette for the roof and not sort of have these dream plant palettes designed for plants that are definitely going to survive and be drought tolerant, and take into account a sun study. I mean, pretty easy thing to do that'll really help your plant selection. Plan for a water source, and plan for stressful areas like HVAC equipment, especially any equipment that gives off really hot air. See this a lot in restaurants and stuff, vents like that. All around the vent will just be dirt. I mean, you're better off just building vegetation-free zones in that area. It'll definitely look better.
Is there any concerns related to vibration? Like, I know they put a lot of that stuff on isolators, but can you like vibrate your soil into a more compact state? I mean, is there anything you need to worry about there, or is it pretty?
I don't think so. I've never seen that be an issue.
Okay.
I have a slide coming up on maintenance, but it's also mentioned here. So the main concern about maintenance is that plants that aren't drought tolerant will overtake your drought tolerant plants in ideal growing conditions. And then when that drought comes, your whole roof will be brown. So, I mean, maintenance is important, and it's definitely project specific, how much weed pressure you're getting. But,
Interesting.
we always advise some maintenance at least. And things like soil testing and soil amendments at the beginning of the season are huge. If you can get out onto a roof and spread like a pre-emergent that will stop anything that went to seed from growing, I mean, the amount of time you have to spend on a roof is cut in less than half.
What would an example of that be? That's an interesting concept. I'm not familiar with that.
Oh, an example.
What would an example of like a pre-emergent be?
Pre-emergent we use
Corn gluten is a natural pre-emergent that's also in it. Preen is the common brand.
So it doesn't
also has a
bother anything that's
chemical.
established, but it
No.
prevents things from, becoming established.
Yeah.
Interesting.
It kills weed seeds before they germinate. It prevents the germination process.
This is an example of some of those more dreamier plant palettes. You can see the waves that were designed in here. And these monocultures of plants that were used to make these,
This was a green roof we did not install. I want to preface that as well.
right.
We were brought in, I think, year 4 or 5. And we were told, if you don't fix it and make it look good, we're gonna astroturf it. And you have 1 year, so.
Yeah, they knew how to push buttons.
They tried to create patterns with the plant material, as you can see in the renderings, and had monocultures, and green roof is just a very diverse environment. You don't look at a meadow and find any less than 5 species typically. You wanna have variety, and you want to, you're never going to be able to maintain those specific lines with succulent plants. So we have over 40 species there of plant material. It's thriving. So.
It's got kind of an alpine sound vibe too.
Yeah, I think that's the light conditions and probably the season too. I mean, it's amazing how these things change color wise from spring to fall to winter.
Yeah, and there's several stories at the Four Seasons coming up on the west side of it. So there's very unique sun conditions and shade conditions. The sun study was never done there to really better understand what was needed for the plants.
Yeah, we recommend typically you're looking at 3 to 4 visits a year while the plants are establishing, and then 2 to 3 afterwards.
About 25 cents a square foot on average for a lot of extensive green roofs per year.
Yeah, and your maintenance requirements are going to go up if you have weed pressure. You know, if you're lower to the ground, if you're near other vegetated areas that are going to be throwing seeds up into the air. And
Have you had any issues where just like exhaust from vehicular traffic has been a major issue, or not really?
No, not really. Not really. Water quality sometimes, at the hose bibs, we had one issue where, it was, the water was not, they were flushing
it was
the,
chlorinated, yeah.
Yeah, but something.
and we were establishing it with temporary irrigation.
So this is sort of some of the things that we would do with our maintenance contracts. Add new plant material during cooler temperatures in the growing season for better establishment, midsummer plants. I mean, some of these roofs will open up to some bare spots, and it's great to like keep them vegetated. The cool thing about the sedum species particularly is that if you have one area that's doing great, and there's these big patches of sedums coming up, you can just grab a big handful and tear them right off of the plant and put them in a bare spot, tamp them down, and they'll self-sow. So a lot of the times when we're sort of repopulating areas of a roof, we'll take cuttings off of that particular roof in areas where it's doing well, and allow those cuttings to populate other areas.
We've had a couple of people jumping off saying, thanks a lot. And
Yeah, I think
there
we're
was
running.
one question about whether the slide deck might be able to be circulated.
Absolutely, yeah. I'll send this as well as a few. I think if there's a transcription of this chat that you could send me, I'll make sure to send any data sheets as well that we talked about today.
Cool.
I think we're pretty
yes,
much at the end
we'll
anyway.
make the slide deck though.
Look at that. There's the last slide.
Awesome. Wasn't trying to rush you there, just wanted to catch that guy's response before he headed out. But yeah, it's really, really interesting stuff, guys. Thank you so much.
Thank you very much.
Any,
Thanks
any
for having
final
us.
questions from anybody else online here? Looks like we had a pretty good online attendance actually.
There we go. Coastal go up one.
Well, we already covered that one. I think the answer was yes, no issues there.
Right. Okay. Thank you, guys.
Yeah, absolutely.
Yeah, thank you so much. I'm going to wrap up the recording here, I guess. All right.